Right, we're looking at Mr. Ridley's RMT revision, and this is number 11, Smart Materials and Composites. So we're looking at smart materials and composites, and first of all we're looking at composite materials. So composite materials generally are a different class of resistant materials. The word composite comes from the word composed, which means made up from. They generally have two different components. When added together, they have outstanding characteristics such as high strength in comparison to their weight. Composite materials. The main group of composite materials that we're looking at are FRPs. These are fiber reinforced polymers. We're going to look at three of these. These three are, the first one is GRP, and that is glass reinforced plastic. This is used for boat hulls and on some sports cars. To make GRP, a polyester resin here, a liquid resin is mixed or brushed onto glass fibers. When the fibers are saturated, the material the resin then hardens, and it makes a very rigid, lightweight product, which is a composite product. GRP is strong. It's not quite as strong as carbon fiber, and it's not quite as expensive as carbon fiber, but it's still very good for metal compared to some metals like steel, and it can be easily molded into shapes like the boat hull there. The next product is carbon fiber. Carbon fiber is produced in a similar way to GRP, but it has a lot of advantages. It's much lighter, it's much stronger, but it is more expensive. And here it is used for a high-end sports car here, carbon fiber. Carbon fiber is also used in Formula 1, and there's a McLaren body tub. It's used because it's very lightweight, very rigid, very strong. The next material, Kevlar, is a similar material to carbon fiber, but the strands are immensely strong and incredibly resistant to cutting and tearing. So if it is woven into a tight fabric, it can stop knives here, or even bullets. And bulletproof vests made from Kevlar. Now we're going to look at smart materials. What are smart materials? They are materials that have a reactive capability. So when something happens to them, they do something else. This means their physical properties change when they're influenced by something else. So something happens to them, they change. So the first one, SMA, shape memory alloy. These Memoflex glasses, you can see, have the capability to return to their original shape after they've been bent. It's available in all different materials, but it's used there for those glasses that spring back to shape. Thermochromic pigments. These are paint or pigments that are sensitive to temperature. When they're heated up or cooled down, the colour changes. So this property is useful in indicating if the drink is hot. So you can see here just a coffee cup. It's black. As the ceramic and the pigment heats up, it changes to white. They're also used for things like baby spoons that can tell if the food's too hot. So that's thermochromic pigments. Polymorph. This comes in the form of small white granules. It has the ability to be reshaped at temperatures as low as 60 degrees. So when it's just pour boiling water over it, and it's easy to shape, and then it hardens when it cools into a tough plastic. And it can often be used to make ergonomic prototypes, like this spoon handle here, quite easily. Now we look at nanotechnology. This is the science of manipulating matter at the nanoscale, down to 100,000th of the width of a human hair to create new materials. So we can see here a head of a pin is 1 millimeter, and the carbon nanotubes are much, much smaller, just 2 nanometers there. Yamaha used nanotechnology to produce a shell for their jet skis. This is hundreds of times stronger than steel, but 6 times lighter. So it produces something that's very rigid, very lightweight, using nanotechnology. Now, it's time for questions. First of all, smart materials. This material is polymorph. This material is used to form ergonomic hand grips. This material is shape memory alloy. This material is used to make glasses that retain their shape. Nanotechnology uses component materials that are they 1 mm, 0025 or 0.2 in diameter. It is of course carbon nanotubes used in nanotech materials are absolutely tiny, nearly molecular in thickness. It's nanotechnology. Which smart material changes in response to changes in temperature? Which smart material is it? It is thermochromic pigments. They are sensitive to temperature, they change colour when heated up or cooled. Composite materials. This material is carbon fibre. This material is used to make F1 racing cars. Another composite material. This material is GRP. This material is used to make boat hulls. This composite material is extremely resistant to cutting and shearing. It's Kevlar, very resistant to cutting and shearing, used for bulletproof vests. Okay, that was smart materials and composites.